Hey guys, today we are going to be starting a new unit, so I hope everything's going well for you. Today we're going to be just reviewing some skills that are really going to help us with this unit. Now this unit, we are finally starting quadratic equations. So that means you're going to start seeing squares and stuff like that in your equations. Let's go ahead and dive in. The first skill that we really need to review is greatest common factor. Now this is something you've been doing since elementary school, middle school, okay? But all we're going to be doing is we're thinking what a greatest common factor is. Well, a greatest common factor is like the biggest number that two numbers have in common. So for instance, like the greatest common factor of 4 and 6 is 2, because 2 goes into 4 and 2 goes into 6. Another example would be like the greatest common factor of 9 and 15 is 3. 3 goes into 9 and 3 goes into 15. So it's two really quick examples, but we're looking at GCFs in terms of our expressions here. So first, let's talk about this word. So this word here, terms. Now a term is separated by a plus or a minus sign. So in this case, we have two terms. And we're going to be looking for the GCF of each of those terms. So we're thinking, what is the GCF of 25x and 15? What goes into both 25x and 15? Well, for this one, my GCF is going to be 5. 5 goes into 25 and 5 goes into 15. So we're going to be practicing pulling out that GCF, okay? And we're kind of making a new equation. So I want you to kind of think about this as reverse distributing. Whenever we distribute, we take our number, we multiply it to both, right? Well, with reverse distributing, we're pulling out a number. And it'll make more sense why this is so useful to us later. But right now, we're going to pull the 5 out of the 25x and the 15. But the thing is we need to divide every term by the GCF. So 25x divided by 5 is 5. So on the inside here, we're going to have a 5x plus. I also need to divide this 15 by 5, and 15 divided by 5 is 3. So it's kind of like reverse distributing. Look, if I were to distribute this problem, if I were going to go 25 times 5, 5 times 3, it would get me back to where I started, okay? So let's take a look here at this next one. Let's determine and factor out the greatest common factor. Here, though, I have three terms. We have a negative 2x, a negative 8x, and a 4. Don't let that scare you. We're just going to divide all three. There is something that I need to make sure that you see, though. It is this right over here. If the first leading term is negative, the GCF must be negative. So look at this. We have a negative right here in front. So my GCF that I pull out has to be negative, okay? So my GCF on this one, since my starting term is negative, my GCF is going to have to be negative. So let's look at what the numbers have in common. We have a 2, an 8, and a 4. So what's the largest number that goes into 2, 8, and 4? Well, it's going to be 2, okay? 2 goes into 2 one time, 2 goes into 8 4 times, and 2 goes into 4 twice. But remember, this has to be a negative 2. So we're going to pull out a negative 2. But that means that I'm going to leave in, well, we're going to have to divide each one of these by my GCF, okay? So negative 2 divided by negative 2, as we pull it out, that's just going to be a positive x squared. Negative 8 divided by negative 2 is going to be a positive 4. And 4 divided by negative 2 is going to be a negative 2. Okay? So that's all we're doing. We're just pulling out GCFs. Let's take a look here at this one. What's the GCF for this one? Well, my GCF for this one is just going to be a 3. So we're going to pull out a 3 in this one. Okay? So I'm just going to pull out a 3, which means we're going to have to divide each one of these by 3. So 6 divided by 3, we're going to have 2x squared Oh man, sorry guys, over here I forgot my x on my 4 right there. How silly of me. So that x should be there. Okay, so 2x squared plus 7x plus 6. All right, last one here. Determine and factor out the GCF. Okay, so you'll notice something here. We actually have a x in both of them. And if they have an x in both of them, that means we have an x in common there. So my GCF for this one is going to be, well, they have a 3 in common, and they also have an x in common. That's really important, all right? So there you go. We're going to have to divide this by 3, divide this by 3, and we're also going to divide it by an x and an x. So we're going to pull out a 3x, and so we're just going to have a regular old x here, and we're going to have a 2. The best way you can check yourself on these to see if you did it correctly is if you distributed, if you did 3x times x and 3x times 2, does it get you back to where you started? And in this case, yes, it does, okay? So that's important. All right. Here we have negative 3m cubed minus 2m squared plus 4m, and we're thinking, what's the GCF here? But we also have to remember, if my leading term is negative, I must factor out that negative. We cannot leave a leading term negative. So my GCF on this one is going to be, they don't have any numbers in common. 3, 2, and 4, there's nothing that goes into all three of those other than 1. But they do have an m in common, right? They each have an m, so we can pull out an m. So we're going to go, my GCF is negative m. So my GCF is negative m, and so we're going to divide this by negative m, divide this by negative m, and divide this by negative m. So 3m cubed divided by negative m is a positive 3m squared. Negative 2m squared divided by negative m is a positive 1m. And then positive 2m. Then 4m divided by negative m is going to be a negative 4m. All right? So remember, pull out a negative on the front. And then last but not least, determine and factor out the GCF of this one. X squared plus 4. My GCF is going to equal, well, nothing. There is no GCF. We cannot factor this. There's nothing in common. Okay? There's no number in common, and my 4 doesn't have an x with it, so there's no x in common either. Okay? All right. The next thing that we're going to do to kind of review our skills to get us ready for all of this factoring is we're going to practice with our x's. Now, what I mean by that is we're looking at the pattern, okay? And then we're going to practice filling in that pattern for ourselves. So let's take a look here. What patterns do you see from the following? So here's all these x's, and I want you looking for what pattern you see here. Well, I'll tell you what I see. I see the two numbers on the side multiply to make the top number. So these two numbers multiply to make the top number, and they add to make the bottom number. Look at this. 3 times 2 is 6. 3 plus 2 is 5. The same thing's true here. 3 times 5 is 15. 3 plus 5 is 8. Same thing's true here. Negative 5 times 7 is negative 35. Negative 5 plus 7 is a positive 2, so it works with negatives too. Oh, and our last one here. 10 times negative 1 is negative 10. 10 plus negative 1 is 9. Awesome stuff, guys. Okay, so let's practice. Let's fill in some stuff here first, all right? So we look at our top number, and we're thinking, what two numbers multiply to my top number, add to my bottom number? Well, this one's pretty easy, isn't it? It's just going to be 4 and 1. 4 times 1 is 4. 4 plus 1 is 5. This one's a bit more tricky though. What two numbers multiply to equal a negative 8 but add to equal a negative 7? Let's see. I'm going to build what I call a T-chart. On this side of the T-chart, I'm going to put the multiples of negative 8. And on this side, I'm going to put the sum of those multiples. So, the factors of negative 8. So let's see what the factors of negative 8 are going to be. Well, we could do negative 4 and 2. That would give me negative 2 for the sum of those. That doesn't really work. What about 4 and negative 2? Oh, that'd give me positive 2. That doesn't work. What about negative 8 and 1? Hey, that works. My sum is negative 7. So that's going to be negative 8 and 1. Negative 8 plus 1 is negative 7. Hey, that one works. We got it. Okay, now for this one. What two numbers multiply to equal 12 and add to equal 7? Let's make our T-chart again. So we can go 12 and we can go sum. Okay. All right, so we could have 6 and 2. That makes 8. Kind of close though. We could go 4 and 3. Hey, that makes 7. So there's our answer, 4 and 3. Okay, our last one here, 25 and negative 10. I'm going to make my T-chart off to the side. We're going to have 25, and then we're going to look at what the sum of those are. Okay, so there's that one. There's that one. Okay, so for 25, let's see here. It's a positive 25, but a negative answer. How strange. Well, we could go 5 and 5. That makes 25. I know that. Oh, but that makes a positive 10. How can we make a negative 10? Oh, I know. A negative times a negative is a positive. So I could go negative 5 and negative 5. Negative 5 times negative 5, that makes a positive 25. But it also, when you add them together, makes a negative 10. So that's going to be negative 5 and negative 5. Okay, there you go. Let's turn the page. And we're going to finish this out by just solving by distributing. So we have 3 to distribute. So remember, when we distribute out this is like what I call reverse FOIL. All we are doing is we are going 2x times each one, 2x times this, 2x times this. I shouldn't say reverse FOIL, I just mean like double FOIL. 2x times both of these, and then 1 times both of these. We're foiling both of the numbers in the first one. Remember, okay, this is where we can use FOIL, where we go first, outer, inner, and last. All right? My first 2, my last 2, my outer 2, my inner 2, and then my last. So I'm going to write this out where we're going to do our 2x times my whole thing plus 1 times my whole thing. Okay? And then we can distribute, combine like terms. So 2x times 5x, 2x times negative 4, 2x times 5x is 10x squared. 2x times negative 4 is negative 8x. 1 times 5x is 5x. 1 times negative 4 is negative 4. Then we combine like terms, and we're going to get 10x squared minus 3x minus 4. Now, do you have to write it out this long way like this right here? No. Could you just do first, outer, inner, last? Yes, but technically that's what we did, right? First, outer, inner, last. Okay? That's what we did here. First, outer, inner, last. Okay, but let's try this next one. Okay? On this next one, you'll notice that I have a negative out in front. Now, I'm not going to write this one out the long way. I'm going to do my first 2 first. So I'm going to go 7x times x is 7x squared. Then I'm going to go my outer. 7x times 1 is 7x. Then I'm going to go my inner 2x, 2 times x is 2x. And then I'm going to go my last, first, outer, inner, last. First 2, outside 2, inner 2, last 2. And then 2 times 1 is, of course, 2. Notice, though, that I left the parentheses right here because we still have this negative out in front. We're going to save that till the end. Okay, so then, combine like terms. 7x and 2x are like terms. So we're going to have 7x squared plus 9x plus 2. And then I have this negative out in front. So this negative, unfortunately, is going to apply to all 3 of these. So, because it applies to the entire parentheses. So it's going to be negative 7x squared minus 9x minus 2. Okay, our very last problem. Find an equivalent expression for 2x minus 1 squared plus 4. Now, this is something that most students mess up on. They're just going to go 2x squared minus 1 squared. Unfortunately, what this actually means is that we're going to rewrite this as 2x minus 1 times 2x minus 1. Because whenever you square a number, you multiply it by itself, right? So we got to take that, we got to multiply it by itself. That's what squaring means. And then we're going to go first, it's going to be 4x squared, outer. So we're going to have negative 2x, change colors, negative 2x. Inner, we're going to get another negative 2x. And last, negative 1 times negative 1 is a positive 1. So we get positive 1, and we still have this plus 4 on the end. So now, let's combine like terms. Negative 2x and negative 2x combine, and positive 1 and positive 4 combine. So we get our final answer, 4x squared minus 4x plus 5. So if you see something off on the end, it just means work this out and then combine it whenever you combine like terms. That's all. All right, so there is that simplified, okay? So we're going to get some practice with all 3 of these skills review before we get into our big time factoring. But last but not least, here we go. Are the following expressions work the same? Obviously not. No, right? This is a big old no. They are not worked the same, okay? So this one, we would have to multiply. We would have to use FOIL. This one, we would add, so we would combine like terms. This one, I would have to distribute that negative and subtract. So obviously, they are not worked the same. So just something to keep in mind. All right, guys, I hope this video has been of help to you. As always, let me know if you have any questions.